Bismillahirrahmanirrahim. Today we are going to speak about the surface integral. In this topic we are going to speak about the surface area and then we discuss the surface integral, and the third point will be the integral of a vector field where we will find the flux. Let's start with the surface area. See what I mean by the surface area. Let's start with this, or let's give the statement of the definition. Let f be a function for which f sub x and f sub y are continuous. On a closed region R. Then the area of the surface over R is given by AS equal to the double integration of square root of 1 plus f of x square over f sub x square plus f sub y square dA. We are in this definition, we are speaking about the three-dimensional surface. Suppose that we have three-dimensional space. And if the area is given down R, in the third dimension, we have some surface that will be over the given region R. And that step is where we need to find the area for this one, which is given by the double integration of the square root of 1 plus f of x squared plus f sub x squared plus f sub y squared. So this is the formula for finding the surface area over a given region R. For example, let's find the surface area of the portion of the sphere x squared plus y squared plus z squared equal to a squared. That is above the xy plane. and within the cylinder, x square plus y square equal to b square or 0 less than b less than a. So we need to find the surface area. We can say enclosed between or by the sphere x square plus y square plus z square equal to a square. See that what we have here. We have three-dimensional space, and we'll have a sphere that will be given. This sphere in the three-dimensional space, but this is over the area given by circle or cylinder, which means that it is this part. Should be more accurate there. So we need to find the area of this part of the sphere. This is the meaning of finding the surface area over given region R in the xy plane. So this is R given by a circle, which is x squared plus y squared equal to b squared. And we need to find the surface area. And the surface area given by A is equal to double integration of square root of 1 plus f sub x square f sub y square. So the first step, we need to define the function f of x, y1, f of x and y. We need to find our function, which is f of x, y. And this will be given by the sphere. We write z as a function of f, x, y. So z is equal to f of x, y, which is equal to square root of a squared minus x squared minus y squared. So this will be our function. From this one, I'll find f sub x, the partial derivative, with respect to x. Differentiate with respect to x, we will have minus x divided by square root of a square minus x square minus y square, and also differentiate with respect to y. It will be minus y divided by square root of a square minus x square minus y square. Now, 1 plus f sub x square plus f sub y square will be this one plus we'll have x square divided by a square minus x square minus y square. This is the first one. we square it, plus y square over a square minus x square minus y square, which is equal to a square divided by a square minus x square minus y square. So this will be our function. We're going to integrate this one. So the surface area AS will be the integration over R of the function A square divided by a square minus x square minus y square dA. Where R is the defined by x square plus y square equal to b square. This is our R. This is the circle in the xy plane. Now I need to integrate this one. And since the region in xy plane is a circle, so we're going to use the polar coordinate to integrate. X equal to R sine theta, y equal to R sine theta, where R between 0 and B, and theta will be from 0 to 2 pi because this is complete circle. So AS is equal to I forgot to write this should be under square root. So converting to this to the polar coordinate, we'll have the function is A multiplied by A square minus R square to the power minus 100. R between 0 to B, and theta, this should be R, dr, d theta. Converting the Cartesian coordinate to polar coordinate. R between 0 and B, and theta between 0 and 2 pi. Now we'll integrate this one, taking A as constant outside, 0 to 2 pi. Now to find the integration of this part with respect to R, we can use the integration by substitution. Integration by substitution. Let's just to make it clear. U equal to A square minus R square, then du will be minus 1/2, or what is minus 2R dr, or dr will be minus 1/2 over R du. And we will get minus, the integration will give me minus A square minus R square to power 1/2 from 0 to B d theta. Now evaluate the integration. When r equal to 0 and when r equal to b. So we will have a multiplied by integration 0 to 2 by of. Replace r by b. Let me take this negative outside, minus a outside. I will have square root of a square minus b square minus, now replace r by 0, will be only square root of a square. Theta. And this will give me minus a multiplied by square root of a square minus b square minus a multiplied by theta between 0 to 2 pi. And the final answer will give me minus 2 pi a multiplied by square root of a square minus b square minus a. And since we are speaking about the area, we're going to square unit. So this is the idea of finding the surface area over a given region R. So just the double integration of square root of 1 plus the square of the partial derivative of x and square plus the square of the partial derivative of the function f with respect to y. Then evaluate the integration and that will give me the surface area.